So we're going to do an improper integral using the limit definition. So first thing we do is we write it as a limit as b goes to infinity of 1 to b of 1 over x dx. Now we treat this like a regular definite integral. We'll still have the limit as b goes to infinity. The antiderivative here is the natural log of the absolute value of x from 1 to b. Now we're still just focusing on this part. We'll take the limit here in a second. So the limit as b goes to infinity. Now just focusing on here, we're going to get the natural log of the absolute value of b minus natural log of the absolute value of 1. And the natural log of the absolute value of 1 just goes to 0. So here's what we have to calculate. Well, the graph of ln of x looks like this. So as x goes to infinity, the graph of ln of x also goes to infinity, which means this thing is going to go to infinity, which tells us this improper integral diverges. Now we're going to use this improper integral, this one right here, to show that one of these is divergent or convergent, and since we found this is divergent, we can only use it to test for divergence. So let's look at something that we can do a comparison on pretty easily. If we look at 1 here, notice that the denominator also has an x. So the question is, can we come up with some kind of relationship between 2 plus sine of x and 1? And this is for x greater than or equal to 1, because our integral starts at 1. Well, sine of x is always bound in between -1 and 1. So we know that sine of x is always greater than or equal to 1 for x greater than or equal to 1. Then, is greater than or equal to -1. Now add 2 to both of those, and we get this statement. Divide both sides by x, and we get 2 plus sine x over x is greater than or equal to 1 over x. This is divergent, so we can conclude that this new guy, 2 plus sine x over x dx, diverges by the comparison test.